Jai Hind students, welcome to physics lecture of grade 10. Last time we were discussing about the concave mirror and today we will discuss about the convex mirrors. All of us know about the convex mirror regarding its shape. Let me summarize. A convex mirror is the spherical mirror which is polished from the inner surfaces. So this is the polishing done from the inner surfaces so that reflection can take place from the outer surfaces. So such a mirror is called the convex mirror. If I ask what type of mirror is this, convex mirror or concave mirror? It is not a mirror, but I'm polishing from this side. So I will say that it is again a convex mirror. All of us know that the center of the mirror is called pole, and if I complete this sphere, then its center is given the name of the center of curvature, and a straight line which passes through this pole and center of curvature is called the principal axis. This concept was discussed by us during the definition of some basic terms. Now let's move to to rules for the image formation. Now rules for image formation in convex mirror. Rules for image formation in convex mirror. What are the rules for image formation in convex mirror? This is a convex mirror because it is polished from the inner surfaces so that reflection can take place from the outer surface. This line is called principal axis. This point is pole and this point is center of curvature, and the midpoint of pole and center of curvature is called the focus. Now, if we are having a ray of light, let us say this is the ray of light which is close to principal axis and parallel to principal axis, what will happen after reflection? It appears to pass through focus, but in actual practice it get reflected, it get diverged. Second point is, again, this is a convex mirror and this line is called principal axis. If this is center of curvature, midpoint is focus, this point is pole. If we are having a ray, no, a ray of light cannot pass through focus. Why? Because if it is here, mirror is opaque, it will not allow the light to pass through focus. And let us say that this is the ray of light, right? And this ray of light is appearing to pass through focus. Now then after reflection, it becomes parallel to principal axis. You can say if a ray of light parallel to principal axis, it appears to pass through focus, and if a ray of light appears to pass through focus after reflection, it becomes parallel to principal axis. Next point is, again we have convex mirror. Now let us say this is a principal axis, this point is pole, this is center of curvature, and this point is focus. Now, there is another point. If a ray of light appears to pass through center of curvature, let us say this is the ray of light, and this ray of light, it appears to pass through center of curvature, what will happen? This ray of light, it retraces its own path, and this ray of light, it falls at an angle of 90 degree to the mirror. Here angle of incidence is 0, so angle of reflection is also 0. When it happens, the ray of light, it retraces its original path. Next is again one more point regarding the rules for image formation. Let us say this is the principal axis, and this is focus at the same distance, center of curvature. Now, if we are having a ray of light which falls on the pole, let us say this point is pole, at an angle equal to angle of incidence, then this ray of light will be reflected at the same angle. If I say R is the angle of incidence, then angle I equals to angle R. So these are the rules for image formation in convex mirror. Simple. If a ray of light is parallel to principal axis, it appears to pass through focus. Second point is, if a ray of light appears to pass through focus after reflection, it becomes parallel to principal axis. Third point is, if a ray of light appears to pass through center of curvature, it retraces its original path. And if a ray of light falls at some angle at pole, then it is reflected at the same angle. These are the rules which are quite similar to that of concave mirror, except that in concave mirror, the rays of light, they were actually passing through them, but here in this case they appears to pass. They are not passing in actual practice, but they appears to pass. Now after the rules for image formation, let's do a very important topic, that is image formation in convex mirror. Image formation in convex mirror. Have you ever seen convex mirror while doing lunch? Now this spoon, this part, it behaves like a concave mirror, and this portion, it behaves like a convex mirror. Now image formation in convex mirror. First case is when object is at infinity. When object is at infinity. Infinity means the rays of light are coming parallel to one another. Let us say this is the convex mirror, and this line is principal axis, this is focus, center of curvature, and pole. If object is at infinity means the rays of light are parallel to one another. The ray of light may be parallel to principal axis, may not be parallel to principal axis, but the rays of light are parallel to one another. So what will happen in this specific case? In this case, the ray of light, they will appears to pass through focus. It appears that these rays of light appears to pass through the focus. So what we can say? We can say that image is formed at focus, and nature of the image is virtual. Why virtual? Because rays of light are not meeting in actual practice, they appears to meet, and this image is highly diminished. Virtual image is virtual, erect, and highly diminished. Second is when object lies between pole and infinity. Let us say this is the concave mirror, and this line is its principal axis. This is focus at same distance, center of curvature, pole. Here, let us say this is the object where its image will be formed. So let me draw the rays with red pen so that it becomes very interesting and you can see clearly. Parallel ray, it will pass through focus. So this ray will pass through focus. Will it pass through focus? No, it appears to pass through focus. And what about the second ray? The second ray, it falls at the pole. Let us say it falls at the pole and it is reflected at the same angle equal to this, but this ray, it appears that this ray is coming from here. So what I will find? I will find that these two rays are meeting here. So what happens? This image is formed. If AB is object, A dash B dash is its image. Now can you tell about the characteristics of image? Image is virtual or real? It is virtual. Why? Because rays of light appears to meet. Virtual, erect. Erect means object is above principal axis, image is also above principal axis. Virtual, erect. This is the size of object, this is size of image. So it is small and we call the small as diminished. Diminished image, and where it is formed? Formed between pole and focus. So I can say image is virtual, erect, diminished, formed between pole and focus. This diagram is very, very important. Now, this diagram, it forms the basis. If I say this diagram can explain why convex mirror is used as rear view mirror in vehicles. All of you can see. All of you can see that image formed is erect, virtual, and diminished. So this is the reason that why convex mirror is formed as a rear view mirror in vehicle. If I ask why convex mirror is used as rear view mirror in vehicles, explain it by a diagram. You have to draw this diagram. This diagram is very important. Next is mirror formula. It is same as we have discussed in convex mirror. 1 by f equals to 1 by v plus 1 over u. And what about magnification? Magnification equals to small m equals to image size divided by object size, and this equals to minus v over u. Now can you tell me, for convex mirror what will be magnification? For convex mirror, as far as convex mirror is concerned, magnification is always positive, and magnitude of magnification is always less than 1, because in convex mirror always small images are formed. If I say name a mirror in which always diminished image is formed, you will say convex mirror is the mirror in which always diminished image is formed. Now let's do some questions, problems, so that you can understand these concepts. Now my question number 1, very simple. This is given as convex mirror, and this is pole, it is focus, it is center of curvature. My question is, what is the sign of focal length? All of you know that focal length is pf. F is on right hand side, so focal length is always negative or positive. Positive, because right hand distances are positive, they are not negative. What about radius of curvature? What is the sign of radius of curvature? The sign of radius of curvature for convex mirror, it is also negative, because PC, C is on right hand side, it is negative. Is it negative or positive? It is positive, because right hand side are positive, left hand side are negative, just like in a number line. If I place an object here, let us say A, B, object distance, is it negative or positive? It will be negative. And what about the image distance? We know that image is always formed on the right hand side. So this is A dash, B dash. So V, it equals to P, A dash, it is positive, and this is PA on the left side. Now question 2. So if I ask what is the sign of focal length, radius of curvature, you can say that sign of this is positive. The reason you know. Next question is, an object is placed at 40 centimeter away from convex mirror whose focal length is 80 centimeter. What I am asking, whose focal length is 80 centimeter, right? Find location, nature, of image formed? It is again very simple question. Let's do this. No, this is convex mirror, so its focal length is positive. F is positive. And what about its U? It is negative. 40 centimeter. So I will take it as this. If I say that this is convex mirror, this is the convex mirror, and this is the focus, this is center of curvature, this is pole. So and here object is placed, right? So I have to calculate V and M. Now 1 by F equals to 1 by V plus 1 by U. Put up the values. 1 over 80 equals to 1 by V plus 1 over U means minus 40. So if I say that, what will be 1 by V? 1 by 80 plus 1 by 40. Why? Because when it will go there, it will be positive. This is 81 plus 2, 3 by 80. So V, it equals to 80 by 3. Can you solve this? It is 26 3 is a 78, 26.67 centimeter. Remember that V is positive, it means image will be formed on the right hand side. What is its magnification? Magnification is minus V upon U, minus sign here. V is 26.67, and what is U? U here is minus 80. This is cancelled. If you will solve this, it will be 0.33. What is the SI unit of magnification? It is a unitless quantity. It has no units. So and it is positive. So I will say image is erect, virtual, and diminished. Right? Let's do one more numerical. Question is, an object of height 3 centimeter is placed in front of convex mirror of focal length 20 centimeter. Here I am adding at a distance of let us say 20 centimeter in front of a convex mirror whose focal length is also 20 centimeter. It's an interesting. Find height of image, location, and nature of image. Can you do this? Let's do this. Now, this is the principal axis. This is convex mirror. Let us say this is focus at a distance of 20 centimeter. So object is also placed at a distance of 20 centimeter. This is AB and its height is 3 centimeter. Let us say h1 is its height. And we know that when object is between infinity and pole, its image is always found between pole and focus. This is A dash, B dash, right? Let us say its height is h2. So let's do this. H1 is given to be 3 centimeter positive. Why positive? Because it is above principal axis. Here u is, object is on left hand side. So u will be taken as minus 20 centimeter. Focus is on right hand side. So here f, it equals to the plus 20 centimeter. I have to calculate V, I have to calculate H2, I have to calculate magnification. So let's solve this. One thing that will be coming to your mind, if it appears that object is placed at the focus, but object is not placed at the focus. You can't keep the object at the focus. If you keep the object at the focus, what will happen in that case? In that case, no image will be found, because here it is polishing is done. So no reflection will take place. So let's do this. Now mirror formula 1 by V equals to 1 by U plus 1 by V. This is the mirror formula I have applied. And what is V here? I have to calculate. What is U? 1 over minus 20 plus 1 over, sorry, it should be 1 over F. So this is, so let me write it again. So it can be written as 1 over 20 equals to 1 over minus 20 plus V. So let me calculate V. This will be here positive. So I can write 1 by 20 plus 1 over 20. LCM 20. 1 plus 1, 2. 2 by 20. So it is 1 by 10. So I will say V equals to 10 centimeter. So what is the magnification? Magnification will be equal to minus V over U. What is V? 10 centimeter. And what is U? Minus 20 centimeter. Minus cancelled. Centimeter cancelled. So its magnification is 0.5. It is positive also. What does it mean? Image is erect, virtual, and diminished. Is it clear? Next is, what is the size of image? M equals to H2 divided by H1, and M is 0.5. H2 I have to calculate, and H1 is 3 centimeter. So how much will be H2? It is 3 into 0.5. So it will be 1.5 centimeter. So I can calculate nature, size of image, right, with the help of this mirror formula. Now one more question that is coming in my mind. Very simple question. I think you will be able to answer. I am having a convex mirror. What I am having? Convex mirror. Of focal length 30 centimeter, right? I have placed this convex lens into water. Find change in focal length. What do you think? What will be new focal length? Is it 15? or something else? Answer is that there is no change in focal length. Why? Because focal length depends only on radius of curvature. F is focal length and R is radius of curvature. Write it completely. Because focal length only depends on radius of curvature. It does not depend on any other factor. So I can say that focal length will not be changed. If I give you concave mirror, what will happen? I will get the same result. There will not be any change in the focal length of concave mirror also. Right? Okay, so that's all for today. Thank you. Have a good day.